Okay, here we go.
Yeah.
All right, so I don't remember how far we got in our notes or what the last thing is.
NaOH something.
But let's just make sure we have down the how to figure out how acidic or basic a solution is. So I don't know if I wrote this, but on the pH scale, every change by 1 unit results in an H plus. That's really bad. So on the pH scale, every change by 1 unit results in a H plus or H3O plus concentration by a factor of 10. That's something you need to memorize. So for questions that say, how many times more acidic is this solution than this solution? How many times more basic? Or what is the H plus concentration? What is the OH minus concentration? And then how many times more acidic or basic based on that concentration? So this, again, every unit is changing by a factor of 10. Now the OH minus is going to change as well, but we can figure that out afterwards. This is really how I want you to think of it. So again, for example here, all right, for example, a solution with a pH of 2 is, I'll say 1,000 times more acidic than a solution with a pH of, I'll let you copy down, see if you can figure that out. So if every change by 1 unit is a factor of 10, we have a pH of 2, and I'm telling you it's 1,000 times more acidic than this. What is this? What is the pH of the solution that it is 1,000 times more acidic than? Oh, I found these in the lab area. Rings. Anybody?
Both mine.
Colin, I figured they were.
Are those like
Is
class
this your
rings?
toe ring?
Yeah.
Oh,
yeah.
No, it's his belly
Yeah,
button.
quick, are those class rings?
No. This is like
Just a straight up
a
ring?
greenish, like,
You got that one at the dollar store.
I don't know what. And this is a
Yeah, at the dollar store.
pinkish brown.
Colin's belly,
I don't know.
belly button.
All right, so nobody in here. All right, good. All right, we're getting weirder now. All right, who knows the answer?
My middle toe.
5. Very good. Eyes up here. So you got 2, 3, 4, 5. Right, here's our pH scale, 0 to 14. We don't need the rest of the numbers. We're only focused on these. So if we start here, we go 1, 2, 3. So that's times 10, times 10, and times 10. Well, 10 times 10 times 10 is 1,000. So if I told you this is 1,000 times more acidic, that means this solution is 1,000 times more basic, so that's why the answer is a pH of 5. So if we have a solution with a pH of 5 and a solution with a pH of 2, they're both sitting on the lab table and you know the pH, this one is 1,000 times more basic than this one, or you could say it the other way around. This pH of 2 is 1,000 times more acidic than a pH of 5. So depending on how the question's worded, it's still 1,000. It just depends on which one you're talking about. Okay? So that's how you answer questions like this. Let me give you another example. This time I will give you the H plus concentration. So they can give you the pH and then ask that question, or they give you the H plus concentration and ask that question. Either way, it's the same thing, so write this down. If two solutions have, let's see, an H plus concentration of 0.001 and H plus concentration of, oh, I don't know, let's go with 0.0001. many times more basic is the second solution than the first. And I admit I didn't word this very well, but once you write it down, your first solution here is the first set of information. There's number one, this is number two. Again, I just kind of did that off the top of my head. I didn't think about it too long there, sorry. So if this was a Regents question, they would make it clear as to which one they're talking about. But so here's your first solution, here's your second solution. They want to know how many times more basic is the second solution than the first. This is a little bit harder. The first question that we just did, I gave you the pH. I think that's easier because you know the pH. Here, they give you the H+, so you have to first find the pH of each one, then remember the factor of 10, and then figure out the answer. So the first step here, write down the pH for number one, pH for number two. The pH of number one and the pH of number two. Do that first, and then you can figure out how many times more basic or acidic, again, depending on what they are asking. Come around and see these pHs. I want you guys to write those down. pH number one, pH number two. All right. So some of you struggling with figuring out the pH, or you're just waiting so you don't want to screw up your notes. I guess that's okay. Can we all put this in scientific notation? If we can't, then you're going to be a little bit in trouble here. This number here, so 0.001, Matt, is this on there?
Yeah.
Okay. Is 1 times 10 to the negative 3. Okay? That's what that number is. That's your H+ concentration here. This one, 0.0001, is 1 times 10 to the negative 4. That is really helpful because now, like Adam answered that homework problem, this number one solution here has a pH of 3, and this one has a pH of 4. If you can't put this in scientific notation, or you don't understand the decimal points and exponent, if you're having trouble with that, then you're really going to have a hard time figuring out the pH, because that's the trick. So if the pH for number one is 3 and the pH for number 2 is 4, then this is 10 times more basic than that. So the answer to this question is 10 times more basic. So this is 10 times more basic. 10 times more basic. Why? Because it's 1 unit larger on the pH scale. Questions? So I still got a minute or two, but tomorrow when I do demos using indicators, there's a worksheet. It's kind of like guided notes type thing. You're going to be answering some questions just like the homework due today, and then just like these. Okay? So you're going to kind of take everything we've been talking about and see how we do on that worksheet tomorrow. Now, before we pack it up, go to table M. Okay, table M, acid-base indicators. The other day I showed you phenolphthalein. I think Trevor answered, you know, how do I know, because I had it up here with the pink and the colorless, how do I know which one's which? Well, if you look at the pH range, and again, tomorrow's going to make it very clear because you're going to see it. But if you look at the pH range, bless you, not all of them have the same pH range, right? So if I have this solution here, number 2, let's use this quick example. And I put, I don't know, methyl orange in this solution right here, number 4, pH of 4, methyl orange. No, let's not use, that's a bad example. Let's use brown thymol blue. Go to table M, look at the second one, brown thymol blue. pH of 4. What color do you think it would be? What color do you guys think it would be if I put brown thymol blue in a beaker with a pH of 4?
Colorless?
Well, there's 2 options. There's yellow and blue.
Didn't you say
Yellow.
Look at brown thymol blue. Are you looking at table M?
It'd be more yellow.
So, yeah, you're right. The phenolphthalein would be colorless, but brown thymol blue would be yellow. Why?
That's closer to 4.
It's closer to 6.
So you see how brown thymol blue at 6.0 to 7.6? Everybody see that?
Yeah.
Okay, hold on, don't move. This pH and less is yellow. This pH and higher is blue. That's how we read table M. Tomorrow we will use that and learn how to use that a little bit better. So don't forget.